did just now.
The human brain is incredibly complex, and it can do some pretty spectacular things, from storing a lifetime's worth of memories to being able to function even if half of it is removed. Another one of the brain's incredible capabilities is its ability to be aware of itself and allow people to know what they're thinking and feeling. Philosophers including Plato and Aristotle have been studying the concept of self-awareness for thousands of years. But in the last century, neuroscientists have started looking at what it means for the brain to observe itself. This concept of thinking about thinking is called metacognition, which means meta or higher thinking. Metacognition involves monitoring our thoughts and internal state and changing our actions accordingly. Our brain's function can be thought of as having two levels, the object level and the meta level. The object level is responsible for processing information, which typically happens on a subconscious level, meaning your brain can do it almost automatically. So if you consider your schoolwork, the object level allows you to process what you're reading or memorize from flashcards. The meta level monitors the object level and is what we typically refer to as conscious thinking. The meta level helps you do things like use a new study strategy or evaluate your progress with a certain skill or subject. The meta level has two parts, monitoring and control. Monitoring is the awareness of object-level brain processes, while control is the ability to act and make changes to behavior based off of what is observed. So, in terms of metacognition, we can think of the brain as a system that can observe its most basic workings and then adjust accordingly. But where do we go from there? While it can be hard to study this topic since an awareness of the self is very subjective, researchers have come up with various experiments to study it. These experiments typically involve a subject performing a task and then rating how well they did on it, or answering questions and then rating their confidence level. Then, researchers can see the relationship between metacognitive abilities and task performance, and they can even monitor the subject's brains during the experiment. We've learned this semester that a lot of the brain's higher-level processes come from the cerebral cortex, specifically the prefrontal cortex, which you can see here, and metacognition is enabled by these structures as well. Various studies have traced the monitoring and control processes to several parts of the prefrontal cortex, including Brodmann area 10 and the medial prefrontal cortex, which again are shown here. In one study, researchers showed that these areas were more activated when subjects were asked to make a judgment about their performance on a visual task. They also found that the size of these brain structures was correlated with how accurate the subject's judgments were. There's also a brain structure called the anterior cingulate cortex, which monitors for inconsistencies and internal conflict. It helps match what your subconscious expects to happen with the reality of actual events. This is really important in learning. The anterior cingulate cortex becomes activated when, for example, you feel confident that you answered a question correctly but find out that you didn't, which will cause you to evaluate how you got to that answer and probably do something different next time. One research study found that the anterior cingulate cortex is also activated in what's known as the Stroop test, which is when people are asked to say the color of a word, not what the word says. When there's a mismatch between the different inputs that your brain is getting, it struggles to do the task efficiently. The brain's monitoring of expectations versus reality is crucial for successful learning because it allows you to adjust what you're doing so that you can do it better. As your awareness of how you're doing a task improves, you actually start to find new ways of doing it. And as we've learned, your brain can actually make new synapses and connections to allow you to do tasks even more efficiently, which is pretty incredible. In school, metacognition is a valuable skill to practice. It can help students master concepts instead of just gaining a surface-level understanding that is quickly forgotten. Increased self-awareness helps students set goals, ask more effective questions, and apply useful strategies. It even helps us regulate our emotions and relate to others. Along with this awareness of how you learn, there's also a form of self-awareness called spontaneous metacognition, which happens when the brain detects conflict within the signals that it's sending. At any given moment, there could be thousands of action potentials firing inside your brain. These action potentials allow signals to be passed down neurons that then send messages to each other. So spontaneous metacognition occurs when signals in different parts of your brain send messages that contradict each other. You immediately become aware of this happening because the object level gets confused and needs some meta level control. So, for example, this occurs when you can't remember a word, but feel like it's on the tip of your tongue, or when you experience deja vu. Because one part of your brain is sending you a message that says, well, I remember this word or this experience, while another part of your brain sends a signal that says, well, I can't call up the word or say the experience. I'm gonna pause for a breath, okay. This detection of conflict also comes from the anterior cingulate cortex, which tells your brain to pay attention when it senses that there are conflicting messages being sent. Both spontaneous metacognition and more conscious, chosen self-awareness reveal that your brain is wired to detect conflict. The complexity of our brains is bound to lead to some minor setbacks, and the purpose of higher-level thinking is to address these small issues. This feature of the brain originally may have evolved to help us make decisions when we face choices for responding to a threat, but now it also lets us choose how we learn and understand ourselves better. Understanding metacognition also helps us understand consciousness and the idea of the self. Metacognition teaches us that while we don't need to observe all of the most basic workings of the brain, we can observe our memory and learning. To have a consciousness is to become aware of our thoughts, not simply to create them. And then we can understand the self to be the combination of our thoughts and the actions they lead to. Through all of their conflict detecting and paying attention to learning, our brains are making sure that we make smart decisions and continue to grow and improve. And once we change our own actions, we can communicate with others about our experience and influence how they understand themselves too. Thank you. My bibliography.